landscape elements. The soils kind of do their thing, the streams kind of do their thing, the lakes kind of do their thing, and they're not very well connected, because back home we have rain that rains all over everything, and then the water is just connecting all the soils to the streams to the lakes, or you have animals or something moving through the system. We don't have any of that. Mm-hmm. So the only mechanism where these different landscape elements get really connected would be the wind.
And do the organisms themselves serve as forcings, or not really?
Not so much.
Mm-hmm. And is this environment down here affected by, because you're talking about the rains, and it made me think of acid rain and how, different regions are affecting each other because of the winds. Is the LTER down here seeing an effect from things that are happening in the rest of the world?
Yes and no. In many ways, we're isolated from the rest of the world. We don't really have much of an El Nino effect here, for example. I mean, we've been looking for an El Nino effect for a long time. We just don't see anything, at least not in the response of our system. And in a way, we're kind of an anomaly. In fact, a lot of East Antarctica, where we are, is an anomaly, where the rest of the world seems to be warming up, and we're actually cooling down here. And this kind of adds to the complexity of people's understanding of climate change. This is going to be a little bit of a long-winded answer, but see, climate change, everybody wants to simplify it to say, oh, everything's warming, but there's different patterns to this, and there's no reason to think why the whole Earth should warm up uniformly across everywhere. Why can't there be differences across the globe? And Europe might be warming faster than the U.S. because of the way the winds are flowing across the Atlantic, and then it might shift because of the wind pattern shifts across the globe. Well, for us down here, what we're having is, the best of our understanding, is we have the ozone hole that occurs mostly in the winter, and we're losing heat out of the ozone hole. And as the subtropics warm and East Antarctica cools because of the ozone hole, you have this temperature difference, which causes the winds to circulate around Antarctica faster. Mm-hmm. And when that happens, when they circulate around Antarctica faster, they isolate Antarctica from the warming at the higher, I guess it's the lower latitudes. Mm-hmm. They isolate it from the subtropics. So here we're kind of sitting in this this protected area that's losing heat through the ozone hole, so we're cooling down. Mm-hmm. So some people are saying, like in Michael Crichton's book, State of Fear, or Ann Coulter's book, we've been referenced in both.
Oh, you too? Oh, boy.
Yeah, we're proud of that. Yeah, this is great. Yeah, this is great. See, global change isn't happening because they're cooling. Well, there's a way to explain this that's consistent with global warming and the addition of the ozone hole. So what we're finding then is our system, our valley, this finally gets back to your question, our valley is actually cooling down. The ecosystem is responding in the sense that the number of nematodes in the soil are decreasing with time. Our ice thicknesses are increasing, which limits the amount of light. And you limit the light, and therefore there isn't as much phytoplankton, active phytoplankton in the lakes. So our system is responding basically to a cooling event. Mm-hmm. And our glaciers aren't receding. They're they're either doing steady or advancing a little bit because everything gets colder.
So I read some of Richard Byrd's writing, and one thing he says is that weather is born or created at the poles. So it's interesting based on what you were saying about how Antarctica is kind of isolated, but at the same time, does it have an effect? Does the fact that this ice is down here and it's not warming and it's not melting, is that having a positive effect on what's happening in the rest of the world, or any kind of effect on?
Oh, sure, because generally speaking, both poles are losing heat, so we're part of the heat balance of the Earth. If it wasn't for the net heat loss from the poles, the Earth would continue to warm to a much higher degree. So we're losing the heat off the poles, and that's just under normal conditions. That's not under climate change conditions. That's just under normal conditions. There's a net heat gain along the equator because that's where the sun is the most intense, and where the sun is the least at the poles. That's where you have the net heat loss. But weather being generated at the poles, Yeah, for Antarctica, even though we're becoming more isolated, we are a heat sink, and we might be more coupled to the subtropics through the ocean currents that bring a lot of heat in from the subtropics to Antarctica, cools down, and then goes back out.
Mhm.
So it can be a governor, if you will, of the system that way.
Okay. I guess one of the last things I wanted to ask you about is just the kind of unique nature of the LTER. Some of what I've read about it is talking about being one of the first very interdisciplinary programs kind of from the beginning at a time when that was very
Right.
unusual. And I wonder if you could speak to that.
Well, it's very interesting, for me at least, and that is, just because you get a group of scientists together with different disciplines and say go do stuff, doesn't mean it becomes interdisciplinary.
Okay.
Because there's a whole psychology involved in this. Partly it's we're just totally unfamiliar with each other's field. So, for example, my colleague Diana Wall, who does the nematodes in the soil, how am I supposed to be interacting with that? I don't even know what a nematode is. So it takes a while. The learning process takes a while. And then I think there's certain trust issues. Not that it's a conscious thing, like I don't trust you. It's like, I've never worked with you before. I don't know what your habits are, what your culture is. How do we connect in a way that makes a fruitful study or a fruitful collaboration? So that actually takes a while to partly learn what the other disciplines are and partly get used to each other's working style such that we're comfortable working together. So really, it was only after our first 6 years I think we really started doing interdisciplinary work. We were working cooperatively before that and friendly, but not interdisciplinary. It was really only after that I can see what my glacier or weather effects are on the soils, and then begin to ask them questions, and then begin to interact with them on their studies, and vice versa, have them interact with me on mine in kind of a knowledgeable way, in a way that's comfortable for all of us to interact.
And what influence is that having on the scientific research?
Oh, I think it's been great, and you can see it visually, because if you look at our papers, they're initially single-authored or dual-authored, just with people in our own discipline. But as the project matured, it becomes, because it's more interdisciplinary, more and more authors of our colleagues show up on these papers. So, for me, it's really broadened my view of what's happening in the valley, whereas before it was just like, oh yeah, glaciers, and everything else is sort of whatever, Right. Now it's like I have a much wider perspective of how the glaciers are part of the whole system. And vice versa for those guys, people working the lakes now can appreciate how the activity of the soils affect the lakes, that kind of thing.
Would you say that the study, studying climate change and its effect on ecosystems is kind of becoming a discipline in itself, or that the disciplines are changing and transforming because of what's being learned about how these systems are integrated, or?
Well, yeah, what's been happening, and I think climate change has really accelerated this process, that to really understand the system, you can't rely just on atmospheric scientists, because there's interactions with the ocean, the land, the ice sheets, and that's only in the physical side. Then you have the biology in the oceans and on the lands. So now you have to bring in the biology, and we're not even talking about human influence yet. So you can just see that all this is kind of dramatically put together. And if you read any of the climate change information or climate change papers from, say, just the ice core studies, you realize you got to know a lot about a lot of issues. For example, winds bringing up dust, and what does that mean when you have a lot of dust in the ice core? Well, that's from higher winds, say. Well, then what does that mean climatically? So as a glaciologist, then you have to kind of understand a lot about terrestrial systems. Or if you see a lot of methane's produced in swamps. Well, where does that come from? So you sort of got into this whole interdisciplinary world that's critical for us to understand how the system's working. And I think back to the LTER,